So let's go and answer this question here, the derivative of tangent. Well, we rewrote that as sine over cosine. Well, let's do it now. All right, let's go ahead and actually take it. Well, derivative of the top is just cosine. Leave this bottom alone, so leave the bottom alone. Subtracted by, well, leave the top alone, okay. Multiplied by the derivative of the bottom, which is negative sine. All divided by the bottom squared, cosine of x squared. This is going to be cosine squared of x. Negative times a negative turns into a positive, so plus sine squared of x, all divided by, well, cosine squared of x. Well, I don't know if you remember this in particular. This is from pre-calculus. Sine squared of x plus cosine squared of x is equal to 1. So we can replace the entire numerator by 1 over cosine squared of x. And there is your derivative function. And I don't know if you recall, but we also know that 1 over cosine is the same thing as secant of x. Okay, these are the exact same thing from our trigonometric identities section. This is to be true. So what is 1 over cosine squared of x? Well, that's just secant squared of x. Okay, so the derivative of tangent turns out to be y prime is equal to secant squared of x. And there it is. Or 1 over cosine squared of x. And see how we can use the quotient property to help us find the derivative of tangent. And we get a very nice result, so of secant squared. Hopefully that helps you, my friend. All right, so I wanted to talk about how to use the quotient property with 2 different example problems, and then we're going to call it good. I thought these were great ones to cover. So I want you to look above. The table above gives us the values of differential functions f and g and their derivatives. So notice how we have f of x, f prime of x, g of x, and g prime, and they give us values here. If h of x is equal to f of x over g of x, okay, what is the value of h prime of 1? Now, this is a great question, and you have to ask yourself, well, what do you notice right here? Well, we have a division symbol with a numerator denominator. That's going to require the quotient property. So if I want to take the derivative of this, well, we take the derivative of the top. Now there's no function given to us, so we'll just write f prime of x, right? We're taking the derivative of f, okay? Multiplied by, leave the bottom alone. Subtracted by, leave the top alone. Multiplied by the derivative of the bottom. All divided by the bottom squared. Okay. All right. Well, now we can plug in 1, right? We're going to plug in 1. Let me change colors real quick. We're going to plug in 1 for x. Now that we've taken the derivative, all of these are going to be 1, 1, 1, 1. Okay. And this would be g of 1. So if I want to do that, well, let's just go ahead and, well, what's f prime of 1? Well, f prime of 1, here's 1, right? F prime of 1 is 4, just looking at the table. So we're going to get 4. So I'll just go ahead and write it 4 times, well, g of 1. Well, g of 1 is just 3. So see how I'm just looking at the table, minus, okay, what's f of 1? F of 1 is 2. Multiplied by g prime of 1, which is negative e. All divided by, okay, g of 1 squared. Well, g of 1 is 3, so we get that, okay? So we're going to get 12. Negative, negative become positive, so plus 2e, all divided by 9, okay? All right, well, there it is. Now let's look at the table. Well, 12 plus 2e divided by 9, there it is, d. So notice this problem didn't even ask us with anything in regards to equations. It was just functions and tables, and the process is still the same. Derivative of top, leave the bottom alone, and we go through that process. All right, so let's take a look at this graph here. This problem, find the equation of the tangent line to the graph of this at 1, 1. Okay, well, first things first, because it's asking for the equation of the line tangent, we know this is y minus y1 is equal to mx minus x1. And are we given points? Well, my friends, we are 1, 1. So we could just fill these in like that. And now we really, at the end of the day, we're just going to ask ourselves now, how do I get the slope? Without the instant slope. Well, to get that instant slope, we need to take the derivative of this. So if we go to take the derivative of this, we have to look at it and know there's a division. That's going to be the quotient. So take the derivative of the top, which is 2. Leave the bottom alone. Minus, okay, leave the top alone, and then the derivative of the bottom, which is just 1, all divided by the bottom squared. Okay. Let's just clean this up a bit. Distribute these across. We get 2x plus 2 and minus 2x, all divided by x plus 1 squared. These cancel. And we're going to get 2 over x plus 1 squared. Now let's plug in 1 and get our slope. 2 over 1 plus 1 squared. 2 over, 2 squared. So 2 over 4, which is 1/2. Okay, and now we can plug it into here. Y minus 1 is equal to 1/2 x minus 1. Boom. And we are done. So notice this process stays the same. We just had to put in additional work by actually simplifying, using the quotient property, and then taking the derivative. And that's it, my friend. Just wanted to go over some challenging problems for you that I thought were good for us